Imagine a mathematical puzzle, a code to crack that unlocks a hidden world of possibilities. That's the essence of a third-degree equation, also known as a cubic equation. These equations involve an unknown variable, often represented as x, raised to the power of 3. Unlike their simpler counterparts, linear and quadratic equations, cubic equations present a unique challenge, demanding a more sophisticated approach to unravel their secrets. They beckon us to delve deeper into the realm of algebra, equipping us with powerful tools and techniques. But fear not, intrepid learner. While cubic equations might appear daunting at first glance, with a bit of guidance and practice, you too can conquer these mathematical enigmas. This essay will serve as your trusty guide, breaking down the seemingly complex process into manageable steps, demystifying jargon, and empowering you to solve cubic equations with confidence. Before we embark on our journey to solve cubic equations, let's first familiarize ourselves with their general form. A cubic equation can be expressed as follows: x cubed plus bx squared plus cx plus d equals 0. In this equation, x represents the unknown variable we aim to find. A, b, c, and d are constants representing specific numerical values. Importantly, the coefficient a cannot be 0, as this would reduce the equation to a quadratic rather than a cubic. This general form provides a framework for understanding the structure of any cubic equation we encounter. The coefficients, represented by the letters a, b, c, and d, dictate the specific characteristics of the equation and influence the path we'll take to find its solution. Our quest to solve a cubic equation begins with a search for rational roots. Rational roots, if they exist, are solutions to the equation that can be expressed as a fraction, where the numerator and denominator are both integers. To uncover these rational roots, we employ a clever technique known as the rational root theorem. This theorem provides us with a set of possible candidates for rational roots. We then test these candidates using synthetic division or direct substitution to see if they satisfy the equation. Finding a rational root is a significant breakthrough in our problem-solving process. It allows us to factor the cubic equation, simplifying it into a more manageable form. Once we've identified a rational root, we can harness the power of factorization to break down our cubic equation into smaller, more manageable components. This process is analogous to dismantling a complex machine into its constituent parts, making it easier to understand and analyze. The rational root we discovered provides us with a crucial piece of information, a factor of the cubic polynomial. Using this factor, we can perform polynomial division or apply the technique of synthetic division to obtain a quadratic equation. With the cubic equation factored into a linear factor from the rational root and a quadratic factor, we've significantly simplified our problem. Now, we can focus our attention on solving the remaining quadratic equation. Section 5, Synthetic Symphony, Streamlining with Synthetic Division. Synthetic division is a streamlined and efficient method for performing polynomial division, particularly useful when dividing by a linear expression like x or r, where r is a root of the polynomial. This technique simplifies the process of polynomial division, making it less prone to errors and more visually appealing. In synthetic division, we arrange the coefficients of the cubic polynomial in a row and perform a series of multiplications and additions guided by the root r. This process efficiently reveals the coefficients of the quotient and the remainder, which in our case will be 0 since we are dividing by a factor. Synthetic division not only simplifies the division process but also provides a visually intuitive way to understand the relationship between the cubic polynomial, its factors, and the resulting quadratic equation. Section 6. Quadratic Conquest, Solving the Remaining Puzzle. Having successfully factored our cubic equation and obtained a quadratic equation, we've reached a familiar battleground. Solving quadratic equations is a fundamental skill in algebra, and we have a variety of techniques at our disposal, including factoring, completing the square, and the quadratic formula. The quadratic formula, a powerful tool for solving any quadratic equation, provides the solutions for x in terms of the coefficients of the quadratic equation, which is x squared plus bx plus c equals 0. By plugging in the values from our factored quadratic equation, we can calculate the remaining roots of the original cubic equation. With the solutions to the quadratic equation in hand, we've successfully unearthed all the roots of our original cubic equation, effectively cracking the code and unlocking its secrets. Section 7. Troubleshooting tricks, navigating common pitfalls. Even with a solid understanding of the steps involved, solving cubic equations can sometimes be tricky. Here are a few common pitfalls and troubleshooting tips to help you navigate these challenges. 1. Missing or extra roots. Remember that a cubic equation will always have 3 roots, although some roots may be repeated. If you find fewer than 3 roots, double-check your calculations or consider the possibility of complex roots. 2. Fractional coefficients. Don't be intimidated by fractional coefficients in the equation. You can multiply the entire equation by the least common multiple of the denominators to obtain an equation with integer coefficients, making the calculations easier. 3. Irrational or complex roots. While the rational root theorem helps us find rational roots, cubic equations can also have irrational or complex roots. If you've exhausted all possible rational roots and still need to find all 3 roots, the cubic formula can be used, though it is more complex than the quadratic formula. By being aware of these potential pitfalls and employing these troubleshooting tips, you'll be better equipped to tackle any challenges that arise during your cubic equation solving adventures. Section 8. Cubic equations. Conquered. Mastering the solution. Congratulations, you've journeyed through the intricacies of cubic equations, mastering the steps to solve these intriguing mathematical puzzles. Let's recap the key takeaways from our exploration. 1. The general form. We began by understanding the general form of a cubic equation, which is x cubed plus bx squared plus cx plus d equals 0, where a is non-zero. 2. Rational root revelation. The rational root theorem provided us with a set of possible rational roots to test, leading us to a crucial factor of the cubic polynomial. 3. Factorization finesse. Using the rational root, we factored the cubic polynomial into a linear factor and a quadratic factor, simplifying the problem significantly. 4. Synthetic symphony. Synthetic division streamlined the process of polynomial division, efficiently revealing the coefficients of the quadratic factor. 5. Quadratic conquest. Armed with the quadratic factor, we employed familiar techniques like the quadratic formula to find the remaining roots of the cubic equation. 6. Troubleshooting tricks. We discussed common pitfalls and troubleshooting tips to help you overcome challenges and ensure accurate solutions. By following these steps and remembering the key concepts, you are well on your way to confidently solving cubic equations and unlocking a world of mathematical possibilities. Section 9. Beyond the solution applications and further exploration. Our journey with cubic equations doesn't end with finding their solutions. These equations have real-world applications in various fields, including physics, engineering, computer graphics, and finance. They are used to model complex phenomena, design efficient systems, and make informed decisions. For those eager to delve deeper into the fascinating world of cubic equations, there are numerous avenues for further exploration. You can investigate the cubic formula, a more complex but general solution for cubic equations. You can also explore the historical development of cubic equation solutions, a testament to the ingenuity of mathematicians throughout the ages. Remember, learning mathematics is a journey of continuous discovery. Embrace the challenges, celebrate the triumphs, and never stop exploring the boundless wonders of this fascinating subject.